Hi, my name is Nick and I'm the CTO of a Spanish company Neoform, the company that is going to revolutionize the way we produce insoles. Let's dive right into the core of our technology, variable density. So this is a demo bar and you may see that the structure of the part is totally the same everywhere. But it is soft on one side and gradually it becomes more and more dense on another side. And we have 20 different densities here. So here is the representation of this density bar from soft gradually to hard, and this is the insole. We can easily divide the insole on any areas that we would like to make soft or hard, for example like this. And then we assign any density according to this demo bar. For example, we just touch it with fingers and decide that, okay, for this very area I would like to have number 4. For this area we would like to have number 14. And it is as simple as just draw on the board where you want which density, and we can do it. For diabetes, the same way we can assign some zone that is prone to ulcers, and we will make, in the center we will make it as soft as possible, and then gradually the density will increase to the standard number that we assign to the set. We call this approach variable density technology. It promotes faster healing, better support, and easy customization for any type of insole. Let's move to some examples. Here are the two standard 3D printed insoles. One is with the special top cover and another one is just fully 3D printed with top layers. They're equally soft in all areas. Let's see what's inside them. Here is the gyroid structure. It's equal everywhere, so that's why the density is everywhere the same. What we can do is change the density of each area without any borders, with a gradual transition from one area to another one, and as a result we can make it hard here, softer here, super soft here, and some other density in other areas. Now let's get to the materials that we can use. We can use very different materials, but I would like to cover here only these 4 because they have very unique properties. So this is a high-flow TPU, one of the most common materials. The main advantage of this material is that it's fast to print and cost-effective. We can print a pair of insoles in just 45 minutes. Another one is BASF 85A. Very soft material, that is the only one that I know that is fully biocompatible. That means that not only the material is biocompatible, but also the products that are printed with this material are biocompatible. And as a result, the top surface is skin-friendly, very soft touch, and just very nice. This material really gives a possibility to make very good surface quality quite fast. The next one is very short. This material is widely used because it is super lightweight. This is the only material that is really foam, because when it prints, it foams and inside the material there is air. The main advantage of this material is that it is soft and very lightweight. For example, this insole weighs just 50 grams and an insole with a standard material weighs more than 70. The main advantage of this material, even not the weight, but the amount of energy that it can absorb. This is the best material for energy absorption. For example, it is the best material for diabetes. And let's move to the 4th one. This material is very different from these 3, because the main idea of this material is not to absorb the energy, but to return it. This is the best material for sports applications. To show how these materials differ, we made a special test. So here are these 4 materials, and we made 4 balls with it. Let's see how a standard TPU works. This ball is very rigid, and it weighs more than all others. So I will try to drop them all from the same height. And once again, this is the same model. So all these balls are printed totally the same. They only have different materials. So number 1. Okay. Let's see how the BASF will work. You see it's a bit more bouncy. Let's get here. The energy return of this material is the most. So it really jumps. More than 70% of the energy is returned. And here is the very short. This material is super lightweight and almost 70% of the energy is not returned but absorbed. And here how it works. That's all. Let's see these balls together. From the same height, the same model. Let's see. Once again. So what other top surface finishes can we do? We can do a standard one with the walls, with the bottoms, but without the top surface. So you will apply your own top material, maybe with the logo or just with some different colors. Another option is this one, because it doesn't have bottom, and as a result it is a really breathable structure. It is very good for diabetes because the air ventilation is very critical for such insoles. Another option is a fully 3D printed top cover. With this material, with BASF 95A, we can make it very smooth and skin friendly. And the last one is the full ready-to-use insole that we can produce. They apply this kind of microfiber Durafeed top cover. It is 2 layers. One is microfiber and the soft underlay. Here is the diabetic insoles. I just want to show how these areas with lower density looks like. You can easily see through, and the rest of the insole has the same medium density, and these materials are just perfect for this kind of insoles, BASF and very short. And of course we can apply the top cover, and it remains very soft in the area that we dedicated to be soft, and just a general very nice touch and density in all other areas. So our printing farm can produce more than 3,000 insoles per month. And we are equally open to small orders and production runs. Drop us a message and get different samples of different materials, try them, test them, and feel all the benefits of variable density technology by NEO4.